Hello. Hello guys. In this video I'm going to discuss Dijkstra's algorithm of finding the shortest path in a graph. Dijkstra's algorithm finds the shortest path between any two nodes in a graph, right? But what I'm going to implement is a modified version of Dijkstra's algorithm in which I will find the shortest path of a particular node from all other nodes. So if I'm talking about a particular node in a graph, then my program will output an array which will contain all the distances of the nodes from that node which are the shortest. So let's start and I'll explain. So my program will output an array that is a vector. It will input a graph, the starting vertex int s, and the number of vertices, right? The array that it will output is this array, and I'm going to initialize this array of n plus 1 elements as infinity, because infinity is the maximum distance. I'm assuming that I have not visited any vertex right now. So if I'm not visited any vertex, then their distance is infinity, okay? But the distance of the source vertex has to be 0, so I initialize that. Now the next thing is, while I am inputting the resultant shortest distances into this vector m, I have to use a secondary you can say a secondary storage for calculation of the shortest distances. So what I use a set. So a set, and inside there is a pair. So the name of the set is, and I insert a pair of s comma 0, right? What this is that this set contains two integers, int and int, and the two integers that I insert is s comma 0. So s is basically the source vertex, right? And 0 is the distance of this vertex to the source vertex. So whatever the vertex or node is stored in this first element of pair, the second is the distance of s from that. So then I start till this is not empty, right? And then I find what is on the top, right? And then I erase this, yeah, okay. And then I say that let me traverse through all the adjacent edges or adjacent vertices of this topmost element in the set. I have used this set as a secondary storage to traverse all the edges, and then I will update the minimum distances and store them in the set again, as you will just see. Right, so I'm doing a simple traversal here, and the edge is from x to y, so x to y. Now the condition is important. If there is a shorter edge from x to y, this means that minimum distance of y will be greater than minimum distance of x plus their weight. Then I will definitely have to update this, but before updating this I will have to remove it from the set. And then I update their distance and then I insert it back. Right, that is all. That is a short code, and then I'll return him. Right. Just making my array. I'm making it a sorry, I have to make a W also here. W is essential. Right, then I also have to make this is also essential here. Right, then I create vector int m which is equal to d called g comma. Fine, let's find the shortest from 0, and the size is, what is the size? That is max v. Right, then I call for int I equal to min v I is less than equal to max v I plus plus c out mi, sorry, right, I think this should do the job. Let us take this graph 0, yeah, the distances are the same. Let's take a different one. All the weights, let's take this only and no one else. This is my graph. These are the distances. The distance of 0 from itself is 0, 0 from 1 is 1, 0 from 2 is 1, 0 from 3 is 2. Right, so yeah, it's an easy code. Let's look at another one, this one, 7. See, there is no 0 vertex here, so I'll just start from 1. In this case the distance will be from, let's take it as 4 just for the sake of it. I'll find the distances from 4. See, so this is the code. Thank you.